Find the least values of a and b which make this statement true. 32 base a is equal to 23 base b. Okay, so we're trying to find what a and b are. So we don't know what the bases are. We're trying to figure that out. We want it to be the smallest. Okay, so the way that we're going to tackle this problem is like this. We're going to split this up into two parts. It's going to be the 3 and then the 2. Okay, so we're going to say that this is 3 times a plus 2. Okay, so you're probably wondering how can that be? Where did I get that? Well, let's pretend for a second that we were in base 10, which is the normal thing that you are in base. So 32 base 10. Okay, you don't really even need to write the base 10 there, so I'll get rid of it. So 32 base 10 is the same thing as 30 plus 2, correct? So if it's 30 plus 2, what happened to this 3? What did it get multiplied by to give us 30? Well, it got multiplied by the base, right? We were in base 10, so it's 3 times 10 plus 2. Okay, so if we were in a different base, if we were in, say, let's say we were in base 5. Okay, so if we were in base 5, then this would be 3 times 5 plus 2 in base 10. Okay, so that would be 15 plus 2 equals 17. Okay, so the same thing would work there. So we don't know what the base here is, so what we're going to do is just distribute as without knowing the base. So that's where we get 3 plus 2, or 3a plus 2 is the same thing as 32 base a. Likewise, this side is 2b plus 3. Okay, so now we can solve for one of the variables. I'm going to solve for b. Okay, so if I solve for b, it means I'm going to take this 3 and subtract it from both sides. So I get 3a minus 1 equals 2b. And then I divide by 2, so I get 3a minus 1 equals 3a over 2. 3a minus 1 over 2 equals b. Okay, so I've solved for b. So now I just need to find something that makes this equation true. I can use, let's start with a to figure out what a is. So we could say that a is 1, right? What would happen if a was equal to 1? Well, a cannot be equal to 1 because there's no such thing as base 1. The smallest base you can have is base 2. Base 1 would mean that you could only write zeros, which would make no sense. Okay, so there cannot be a base 1. So let's try the next one up. Let's see what else makes this equation true so that this gives us a whole number, because we want both a and b to be whole numbers. Okay, so what would work next? So if I plugged in a 2, that would give me 6 minus 1 is 5, divided by 2, that's not whole number. So let's do 3. So 3 times 3 is 8, minus 1, or is 9 minus 1 is 8, divided by 2 is 4. So that one works. So let's say that we think our answer is equal to 3. Okay, so if our answer is equal to 3, we could solve that, but first let's look at the original problem. We've got 32 base a, right? So 32 base a. We're in base 3, assuming if this is the correct answer, we're in base 3. Can there be a 3 in a digit if you're in base 3? Well, the answer to that is no. You cannot have, it's like having a 10 in a single digit. It's not possible because 10 is written as 10 in base 10. Likewise, you can't have a 3 in base 3. So this is another answer that is incorrect. Okay, so a cannot be equal to 3. Okay, so let's go up to the next one. So 1 we thought worked, it didn't. 3 we thought worked, it didn't. What is next? 4 won't give us a number that divides. It would give us 12 minus 1, which is 11, divided by 2, which is not a whole number. So 5, 15 minus 1 is 4. That works. Okay, so let's say that we think that we are in base 5 for a. Let's see if that works. So if we do that, we have this 3a minus 1 over 2 equals b. So 3 times 5 minus 1 over 2 equals b. Okay, given that's the case, that's 14 on top, that's 7 equals B. Is there any problem with saying that this, let me erase this right here, that this first one here is in base 5, and this one, well, let's write that out, 5, and that this one is in base 7. Okay, well, there's no bigger numbers in either one of these than 5, and there's no bigger numbers than 7 here. So yeah, that works. So your answer is A is equal to 5 and B is equal to 7.